on Monday. Yeah, it was like a record.
Thank you for reading my question.
Sure.
I hope so.
I try to if there's space for it. I figured a grad student get in there right away.
I think we are up and ready. Okay, welcome to Weather Watch. I'm obviously not Professor Martin. I'm going to be doing the current weather today, which is exciting because I think the current weather is sometimes more interesting than the forecast. So I'm excited to do this. Could we go to the infrared of this week-long, please, Pete? So here's a look at the infrared from the past week. I'll wait till it restarts. There's several interesting things that come up. We know we got some precip on and off throughout the week. I'll wait till this restarts.
You can scroll through it too if that's easier.
Okay, I think I should be fine having it go through. So here we're restarting. We had a massive storm over the Pacific Northwest. That seems to be a feature we've seen all the time now. Here's our first wave of light precipitation, and this storm went off to develop over the Atlantic. We had another wave. This is sort of the same track of that first storm that is still currently sitting over the Atlantic from this time. We have it spinning. Ontario, Quebec have gotten several inches of snow, just repeated snow from these events. And then one thing that I touched on my forecast last week was watch up south of Greenland here. We had a rapidly developing storm, and it develops a very nice swirl with multiple rings around the swirl, and it got down to 954 central pressure. Unfortunately, it's too far away from any real population centers, so nobody really knows, what the impacts were. But it's still it was a gigantic system. I'll wait for it to come up again here. So it started off, there was one system, and then in its wake, here's our another development. And you can see it stretched all the way down well into the tropics. That's the same cloud band. So that was a nice system. We've kind of gotten these more wimpy circulations over us, but it has brought continuous precipitation for 2 or 3 days. We had it this week. And then you can see at the end, largely there was just a band of higher infrared temperatures. Thank you, Pete. So here's our band, one of the main features of the current weather, and then there's something off the west coast, but there's nothing in the middle part of the country. Towards the end here, and you can see there's another development and system sitting south of Greenland here. So interesting developments, but over our region, just light precip over the past week. And can we go to the Pacific week-long loop of the infrared? I'll do the same sort of recap here. So you can see the Pacific has been active.
That's water vapor one IR.
Yes, IR, please. Thank you. The Pacific has been active. I think we've seen a system sitting over this general region of the world for, most of the weather watches in a row here. And this has continued. We keep getting these developments over the Gulf of Alaska and then into the Pacific Northwest. Particularly interesting one, this system, very nice cloud shield and frontal system. And you can see it moved off into Alaska and is still producing winter storm warnings in Alaska. And I'll wait for it to come back. Here's 2 other systems back to back. And that storm that developed that gigantic cloud shield got down to 965 as it made landfall into Alaska. So you can imagine there's probably pretty heavy snow with this into Alaska and along the mountains in Canada, but very nice feature. And it's producing some of the clouds and precip over the Pacific Northwest into the mountainous regions of Montana today, even though the main circulation of it is still situated over Alaska. I'll let it play once more here. Very nice presentation. We looked at the frontogenesis. It was mainly frontogenesis causing all this vertical motion. You could tell it's very linear as it made landfall. Here's this lingering, maybe precipitation, some cloud cover represented by the lower infrared temperatures at the end here. So that's a look at the recap of our last week of weather. And could we go to my first link I had, please, Pete? So today is the 48th anniversary of the Edmund Fitzgerald sinking. This is one of Professor Martin's favorite weather events, not because of how tragic it was, but because of how interesting it was and how famous it's become. So I pulled weather maps. These are daily weather maps from November 1975, and you can see they made actual notes to themselves on these weather maps. It's pretty interesting. So if we could scroll down to the very last page here. I didn't look too far in depth on these weather maps, but I just wanted to point out this is one of the weather analyses I got from this event. So this is November 9th, I believe. So let's take the very top of this map, I should say. Yeah, Sunday, November 9th. Here's our system sitting over central Kansas. You can see there's a stationary front analyzed all the way into the Great Lakes, and then a cold front back into Texas. And this becomes the system that will develop into the storm that sunk the Edmund Fitzgerald. And you can see precipitation is represented in the shading region. So there's precip all along the western portion of the system. Largely nothing along the cold front and in the warm sector. And this was at 7 a.m. the day before the sinking. If we could scroll down, there's a 500 millibar map. So you can see associated with that storm over Kansas, we were in the downstream region of a trough sitting over the Mountain West. Largely the flow was the parallel to the temperature lines, which are in the dashed contours here. So we had a weak system originally, and it was associated with that trough feature over the Mountain West. So now if we could go to the next tab, we'll go to the day of the sinking. This should be the very first page here. So here's the closest weather map to the actual sinking event. This is the morning of the sinking, which occurred over eastern Lake Superior. Here's our storm. It moved from, you can notice the arrows are indicating where it's moving from. So it moved all the way from Kansas into northern Michigan and the UP. 984 central pressure. You can see there's nice precip along this now cold front and maybe occluded front, and then wrapping around the system. I believe it's all rain at this point, but it was indicated by the ship before it sunk that it started snowing. Waves were 16 to 18 feet, and what else? The wind was close to 60 miles an hour over Lake Superior. So this was a significant event. Not particularly, crazy strong system, but still a substantial storm and enough to create rough seas and sink the ship in this case. And if we could scroll down, we'll see here's our trough feature. It's become more negatively tilted. You can see there's a really sharp curvature maximum we can expect and shear maximum just downstream where our system was located at the surface. And you can see the temperature lines are now, the geopotential height are cutting across the temperature lines. So definitely strong upward vertical motion. This storm bottomed out at 978 as it moved into Ontario just across Lake Superior. And then if we could go to my next tab here, this is a look at the sea level pressure records. We could go to record lows in November. And then let's zoom out. And we'll zoom in on right where the storm was located. Don't know if we can go any further. So I'll read these off, but these are 978.3, 977.8. So this storm, as it moved over into Ontario, set the November all-time pressure records for this part of the world, which is pretty remarkable. Unfortunately, maybe not unfortunately, but no pressure records were set in the American side of Lake Superior, but just in the lee of Lake Superior set pressure records, which is pretty remarkable. And these still stand today, even though this was 48 years ago. So I'll touch on this. So now we can go and look at the current weather over our region. And could we start with the ColorViz satellite loop of North America, please? we'll get a look at, there we go. So here's our current satellite loop. We can see there's another system sitting south of Greenland, more like the one I talked about that happened a couple days ago. We can see large amounts of cloudiness over Canada. Some of this might be snow cover in between the clouds. It's kind of hard to tell from this just color viz loop. We can see active tropics, nothing tropical like storm-wise, but there is a lot of cloudiness and cumulus development. There's a large cloud band stretching from Boston all the way down into Texas here, maybe even stretching down into the tropics southwest of Mexico. And then our clouds over us. We were sunny for 12 hours, and then we got clouds again. Pretty typical of fall and winter of us. But then besides this cloud cover over us and the cloud bands stretching over the northeast and into the south, largely sunny day for most of the United States, I would say. And we'll take a look at the surface obs later, see if any of this is precipitating. But you can see our cold front that moved through is associated with this cloudiness, and our warm air is almost only in Florida at this time. Everywhere else is kind of affected by this cold air that moved over the continental United States. Okay, I think that's all. Let me just make sure. Yeah, I believe that's all. And then there's another system making landfall into the Pacific Northwest, which we'll see in the upper level charts. So can we go to, we'll start at the upper levels at 250 from the super peaks. So here's a look at one level that might have some jet streams. We can definitely see a jet streak right along where that band of clouds is located. There's another one pretty significant south of Alaska and moving into Pacific Northwest. Over our region, we kind of have this zonal flow, maybe some slight troughiness, but largely zonal over most of the United States, aside from this jet streak that extends into the northeast here. And so we can look at if these are polar or subtropical jet streaks. It definitely feels polar outside because of how cold it is. So we can go back and we'll go up a level to 200. And we can notice both of the jet streaks become weaker with height. So that's indicative that they're closer to the surface between these two pressure levels. And then if we go back and we'll go to 150, just complete the analysis, they get even weaker at 150. So these are both polar jet streams because they get weaker with height, they're closer to the surface, associated with more cold air. And one thing I didn't mention is this whole complex that stretches into the northeast. There's another piece that is extending all the way down to the deep tropics, and that actually became stronger with height. So there's a piece of this that is subtropical, and it's sort of combining with the polar jet streak to create this enhanced region of winds over the northeast. But then this jet streak is isolated and is only polar, which makes sense. It's closer to the poles in the Arctic. So we have two main polar jet streaks affecting most of this look at the world here. And so could we go to 500 now? So at 500, we can see we're sort of in this region of general troughiness. Earlier, we'll see it closer to the surface, but there is a slight shortwave feature that is situated just upstream of this trough axis. And that might be one reason why we are in a region of clouds due to the upper level divergence just downstream in that trough. You can see we have a tight geopotential height gradient, strong winds even at this level, strong temperature gradient. We saw that reflected with the jet streak just above this region. Here's our storm sitting over just south of Greenland, very substantial in the ways of geopotential height and temperature gradients. And then there's another system that will eventually make landfall over the Pacific Northwest, and you can see that's also associated with a tight height gradient and temperature gradient. And here's our storm that impacted Alaska, that 965 low I was talking about earlier. And let's see. Oh yeah, and also at this region, we could see, so we had this band of clouds stretching from Texas into the northeast. And so it might be interesting to look at what might be producing those clouds. From this look, at this level, we can notice there is slight confluence where we have winds in the warm air that are going generally to the northeast, and then winds in the cold air going generally to the southeast. So you have a band, sort of, it's weak, but it's right along where we saw that cloud feature, that you're producing confluence, you're squeezing the temperature lines together, produce a thermally direct circulation, so you should get a general region of rising motion in the warm air, and that's sort of what we saw with the cloud cover, portions of the cloud cover for sure, especially the ones stretching down into Texas in the southeast. And then if we go to 700, so we'll go a little lower, we'll see the same sort of confluence. You can definitely see it now, where if I put my axis here, we have winds in Oklahoma coming from the northwest, and then from the southeast over, like Louisiana region. So you have a stronger region of confluence, which is producing that thermally direct circulation, rising in the warm, sinking in the cold. So you'd expect cloudiness in this generally warm air that is still situated over the southeast and maybe stretches into the northeast. There's also confluence happening where you have these winds that are more zonal over Michigan and New York, and then more southeasterly, so you're squeezing these temperature lines as well, and that could explain why we had the continuous band of clouds stretching all the way from the northeast down into Texas here. We can also see more defined our trough that is just upstream of our region, might be producing those clouds over our region. You can see it's not anything particularly significant, so that might explain why it's not precipitating. We just have general cloud cover over our region. And then it's very obvious that there is something going on over Pacific Northwest into Alaska. You can imagine with this trough and the rising motion out ahead of it, you also have all of this momentum and masking slammed up against the mountains. You would expect very heavy precipitation, rain and snow into Canada from this look. And then there's a ridge right ahead of that, at least at 700, that is very clear, but it's well into Canada, so we're not the beneficiaries of the sunnier conditions of it. And then we can go to 850, and we'll look at closer to the surface, maybe some temperature advection. Over our region, we're generally in an area of weak cold air advection, where you can see these winds are coming from the northwest, moving into the warmer air, so it's generally weak cold air advection over our region. We can notice, based on the wind shift, there's a pretty substantial wind shift along that cold front that moved through our region. So you have, particularly in Mississippi, you have 12 Celsius with a southerly flow, and then Arkansas 7 Celsius with a northerly. So you definitely have confluence occurring over this temperature gradient. Another indication why we might have cloud cover and thermally direct circulation based on this advection. And you can see, aside from this obvious feature in the temperature lines over the southeast, the rest of the country kind of has intermittent advection, not really anything substantially cold or warm. And you lose the definition over the mountains because they're just too high in the atmosphere. And then, again, very obviously something happening over the Pacific Northwest and into Alaska here. And so if we could go to the surface now, we'll look at some of the surface observations. So first we could start out over our region. So we got into the 40s, we were in the 30s earlier this morning. You can see here's our cloud cover being observed. Some snow into the UP, Duluth, and then Bemidji, I believe, in Minnesota. Other than that, those snow, and I guess there's snow in Houghton, Michigan, but this is the only precipitation happening from that large cloud band that was sitting over the northern Great Plains. You can see all of the sunny weather with weaker winds, aside from that band of precipitation that stretched from Massachusetts into Texas, and you can see there's intermittent, weak rain, light rain along that. Nothing in the way of thunderstorms or convective, which might be just because you have different layers of the atmosphere and they're all weakly ascending, so you don't have any strong forcing for ascent. You're not going to get that deeper convection, deeper precipitation. And then what's something to note is the dryness of this cold air. So it's not necessarily cold. I mean, it's 60 degrees on the backside of a cold front. That would be really nice in the middle of winter. If that were to ever happen over us, it does not. But you can see the dew points fall into the 30s and the 20s behind this cold front, where they're in the 60s out ahead of it. And even looking into the plains, you get dew points in the teens. So that is largely I would say the main feature of this cold front is ushering in dry air. And with this dry air, you can get cooling overnight, especially when there's no cloud cover. And so that is probably the main reason why it's so cold overnight, and going to be cold overnight into the deep south here. As this front keeps moving, then if we scroll down into Florida, we'll see they're still in summertime temperatures, mid-80s, 86, 87, dew points in the 70s. So they have not felt this front. It's still probably situated well to the north of the peninsula of Florida. But you can see it's already made its way all the way down, almost into Brownsville. Oh yeah, it has moved into Brownsville, Texas with heavy rain. So Florida is the only place that has not been affected by this yet. And if we could look at the Pacific Northwest now, that was the other region we had cloud cover. And so we can see with this cloud cover, we have mist, some fog, and then precipitation along the Olympic Peninsula range. You can see heavy precipitation where we had all of that sort of crashing of all the air moving into the mountains associated with the trough. And then largely just over Canada where we had that ridge, clear skies, light winds, some snow, but largely just a nicer day, just downstream of that trough and downstream of this mountain range here. And then I will end on the radar loop of the continent of the United States. And so here's a look at, we can see widespread precipitation. We saw that reflected in the surface obs, but stretching from Massachusetts all the way down into Texas. Here's that heavier rain we saw deep south of Texas. Rain in New Mexico, but aside from that and these little snow showers moving off the lake, Superior, largely nothing in terms of precipitation for much of the United States. And I believe that is all I had. Are there any comments or questions from anybody? Something they want to see? Okay, perfect. I'll turn it over to Libby then.
You're stuck with me for this. You should go to the Alicia Bender maps. I'm going to do things maybe a little differently than what we usually do. Thank you. This is the way I was taught to give briefings. We're going to go top down at the mandatory levels. So, let's do North America. There's a lot of big patterns going on. Yeah, okay. So we're going to start 250 mil level. Look at the jet, as Patrick described. Right now, strong jet over the northeastern parts of the U.S. We're kind of, when I looked at it this morning, we are kind of in that left edge region. So upper level convergence, supporting a reverse motion, which leads to the cloudiness we saw outside. And if you could step forward, please. You can see that quickly moves out, and then keep going, please. We are, not a lot going on for this forecast. Keep going, the jet exits off east coast. We get a little bit colder air, and then this jet streak forms. However, it only stays to our north. It basically stays on this kind of U.S.-Canada border for almost the entire time it exists. If we keep going forward, it stays there until eventually weakens, moves off to the east coast like the one we just saw. But if we keep going forward, an eye on what's developing out here that came off the Gulf of Alaska, you can see this trough starting to build, and as we keep going forward, it keeps deepening and deepening, and that's going to be our next weather maker, which is next Friday, so a week from today. Next watch, we can hit on it and see what happens. So, I think let's get that deep trough and then off the coast. I think that's all I have for 250.
Look at this.
That,
GFS fantasy hurricane.
right, yeah, I was gonna say, I was watching that. It forms just off of the coast here from like Central America, and then just gets crazy deep and then passes over and dies. So like, I don't know, that's something to keep an eye on. I'm not a tropical person, so I don't know what's happening with that, but it's something to watch for. If we could go to 500, please, vorticity. Yes.
Should be this morning. We'll see.
Yeah, so this is this morning. It's a kind of vorticity scenario where nothing special happening in Wisconsin. If you could step forward a little bit, you can see there is a small band of vorticity that kind of hangs around right there. It might be responsible for the cloudiness that we've seen all day and will continue to see. But it quickly kind of moves out, and then this low develops and then heads north as we keep going. But if we keep an eye on the trough that we saw at the jet level, it develops. And these two are kind of weirdly, like here's the trough, sorry. This one stays, develops up north, but these two, if you watch, are kind of weirdly associated. Like I was talking to Patrick about this morning. It's like, it wants to be its own trough, but then this is kind of a cold front stretching down from this low seen off the coast of the Hudson Bay. Like it's just very long, very strong in this region. You can see the vorticity present, the dips and the contours, very strong. Even the wind shift, like I don't know if you can tell from back here, but on this side, the wind's strong southeasterly direction, but then as suddenly as this hits, strong northwesterly. So strong cold front, and that is what we will see come next Friday into Saturday. Is we seem to be the prime recipients of this massive thing passing over us. Plenty of upward vertical motion on the leeward side of the trough before it gets to us. That's probably where we'll see a lot of this from. And then if you could step
That would be right about the time of the Badger football game against Nebraska, or
Yeah.
6:30.
very interesting going to the football game this week. Next week. Keep an eye out for that. And then, yeah, it stays pretty deep as it passes over the northeast. Is this where the loop stops? I know
Yeah,
hers,
that's as
okay,
far
I know
as hers
hers
goes.
stops kind of early, okay.
Yep.
Because one of these,
I've got some that go out to 380.
okay, I might do that. Because eventually this heads off the coast and deepens like, crazy deep, like we've seen so many times already this winter season. But we can look at that later. Maybe just 700. Precipitate water. So this is just drive home the point that this flow pattern that we saw throughout the entirety of the U.S. is keeping the majority of the moist air to ourselves. That's why we're not seeing a lot of rain on days like today, where there's just so much potential for it. The moisture is just not there. So if we step forward, it kind of stays that way. It keeps staying that way until, if you could guess, our favorite trough comes through. And that is really, yeah, right now. Here's our trough. Right around the time it hits, that's the next time we see moisture in our area. So, yeah, it's going to be associated with our next rainfall. Probably no rain until then, which is kind of sad. I feel like it's been kind of dry lately, except for like, what, Wednesday? Something rain? So just a quick stop on 700. That's all I just wanted to point out. Why we've been dry for so long. The flow is just not letting moisture get all the way up here. If we go to 850, Oh, this one. This. Okay. Here's where we can see what really happens. So, here's how we are currently. Not a lot going on. Colder temperatures. Fine. We have a weaker high pressure system, maybe why we've been so calm lately. But just keep stepping forward. You can watch. There goes one of the lows that develops. And then stepping forward. Let's see. Look, the dip in the cold air. That's the trough that we've been watching this whole time. Cold weather's back. Here it comes. Oh, if you could step back one or two. Sorry, I forgot. I wanted to point something out. Okay. Wait, what? Sorry.
Sorry.
Here, yes, with this system. Okay, one forward. If with this, we might get a little bit of a warm up this weekend. By like a little bit. If you go one more forward, you kind of see weak warmer adventure. We might get into like upper 50s, but if you don't like the cold, that's a nice break for the middle of November. Okay, yeah. So if we keep going forward back to where we were with that significant drop over us, you can see the transition. We're colder temperatures. So with the precipitation and this transition, is it going to be snow? Good question. I don't really think so. I looked at soundings, none of them, it's still in the 40s at the surface, even after this passes. It's, maybe if it develops right, there could be like a sleet, freezing rain type event. But as far as snow goes, I didn't see anything too ridiculous. And yeah, if we keep going, this develops. The people that do get snow is the northeast and the Canadian border. This goes right along the lakes, so they might end up getting a lake effect snow event. Maybe not a super strong one, but it's possible. It's on the right track. But they are going to get a lot of snow from this, regardless. It's just it's fun. Yeah, oh my god, okay. This is what I wanted to talk about. This low that we saw moves off the coast and strengthens rapidly and gets incredibly deep. It's very hard to see these contours, but if you look right there, that's the center of it. I counted on my computer this morning because I can't tell from here. It got down to 976, which is pretty impressive for the short amount of time it took to just shoot off the coast like that, which we kind of see a lot this time of year. So that's pretty interesting. It'll be fun to watch as it heads off the coast of Greenland, see what happens to it. So, I think that's, oh, one more thing, for fun, if we could go to tropical tidbits. So, if we're not getting snow from the event next Friday, you might be asking, when are we going to get snow? If we go to GFS Fantasyland, if you want to preset the master, please, and total snowfall. Just advance this forward. Watch nothing. We get to Friday, nothing. Northern Wisconsin gets some, but we're probably not going to get anything from it. But look, the Wednesday before Thanksgiving, the 23rd, we get an inch of snow, right when everyone wants to go home. And then Thursday, Thanksgiving, 5 inches of snow. I'm not saying this is going to happen. This is the farthest hour out on the GFS. And you should never trust that ever. But it's fun to look at. See, it'd be interesting if it does happen, because that's going to cause a lot of travel problems for really everybody in this whole swath in the Northeast. It's the Wednesday that's the busiest travel day of the year, right? Yeah. So this is going to be interesting to see how this plays out, if it does come true. Okay, that's about it. If anyone has any questions or comments?
All right, sweet.